We're excited and very pleased to present our first panel for the day, which is Data Dialogue. Is bigger data better? Data is everywhere, and every single day, exponentially, more astronomical quantities are produced. Well, your chance to hear it from our experts is how they discuss to capitalize on the power of data with unprecedented insights and opportunities across all industries, while managing the emerging problems associated with big data, from privacy to security to data quality. Maybe before that, as a precursor, also remind everyone that this will be a very unique panel discussion which involves engagement, as how Steve has also mentioned in his speech earlier. Please engage us. This will be the gateway for you to partake in our Q&A segment. May we please invite you to visit slido.com and please key in the event code, which is hashtag Deep Tech Summit, all joined together. So something we do encourage you. Also, for our overseas delegates who are joining us, you'll be happy to know that Wi-Fi is complimentary. Please look for MICE hotspots for MBS. With that being said, it gives me great pleasure to invite our distinguished panel on stage. Starting firstly with our moderator, Mr. Steve Leonard, founding CEO for SGInnovate. May we also invite Professor Chen Tsuhan, Chief Scientist, AI Singapore, and Deputy President for Research and Technology for National University Singapore. Bignone, Digital Transformation Leader, Asia Pacific from Airbus. Dr. Andy Cheadle, Engineering Director for McLaren Applied Technologies. Dr. Joe Fitzsimmons, Principal Investigator, Center for Quantum Technologies. And Shankar Selvadurai, CTO, Cloud, Data, and AI Solutions from IBM Asia Pacific. Please do join me in giving them a big, broad, and collective warm welcome, please. And on that note, I hand the stage proceedings over to Steve.
Okay. Hey, all right, thank you very much. What I'd like to do, if I get Mike, what I'd like to do is make sure that we're talking about the things that are important to you. This topic, I think, is such a critical part of whatever we're going to be exploring during the rest of our Deep Tech Summit, because data, without overusing the expression, but data being such an important component, the fuel, as some people call it, but data is so critical. And there's so many tricky edges around gathering of data, storing of data, communicating and moving data. What are the rights and privileges? Is it data for the individual? Do they own it? Is it something that belongs to the entity with whom they're working? So many different aspects. And an incredible panel of individuals here that are all experts and leaders in their own right. I would never do justice to them to try and introduce them, so I always want to allow individuals to better articulate themselves. So what I'm going to do is start off with my friend Tsuhan. Tsuhan, please.
Thank you, Steve. Tsuhan is the name. Thank you, Steve, for the invitation. Out of my role as Chief Scientist for AI Singapore, a national program cross-cutting universities, government agencies, and companies trying to promote artificial intelligence technologies here in Singapore. My day job, serving as Deputy President, responsible for all the research and technology activities on the campus of National University of Singapore. Among all the administrative roles that I hold, I am also a true and hardworking researcher myself. Started out as what you would call image and video analytics during my years with AT&T Bell Laboratories. Many of you probably don't even recognize the organizations anymore. After that, I moved on to Carnegie Mellon University and then Cornell University, working along the line of pattern recognition, computer vision, and machine learning. It's only remarkable to note that while I've been pursuing the same line of research for the last 30 years, but only in the last 5 years, all of us in the community are moving toward artificial intelligence. So this wave of AI is definitely not something that's to be taken lightly. Of course, many of you already see that. So I'm very glad to be here, and I wish I can share with you some of my observations and hopefully insights with all of you later.
Thank you very much. Frank, do you want to jump in?
Hi. Thank you, Steve. So nice to meet you and nice to be here. Thank you for the invitation for this dialogue. I'm from AI and computer vision and robotic backgrounds many years ago, whereafter I started as a research assistant in ETH in Zurich. And then after that, I quickly joined a small startup at that time. It was called a spin-off from a university. And I started in a computer and software environment, developing some software for computer vision and then selling the software, and quickly moved to Asia more than 14 years ago now, in Japan, China, and in Japan now, where I'm working for the digital transformation for a big group, Airbus, helping them to use new technology, deep tech, to see how big data can be used for helping Airbus, and enjoying what I'm doing, and happy to share this experience with you here today.
Thank you. Andy, do you want to jump in?
Thank you, Steve, and good morning, everyone. I'm Andy Cheadle. I'm the Engineering Director for McLaren Applied Technologies, where I lead our engineering functions across hardware, software, simulation modeling, and data science. I'm a computer scientist and software engineer by background. Spent a number of years in academia working on programming language design and implementation for decision support systems and virtual machines. And then as an industrial software engineer, I've worked across telecommunications, call processing software, and soft switches. I've done a couple of startups in IP network modeling and capacity planning, and more recently spent time leading the National Cyber Defense Solution development for a large defense company. Within Applied Technologies, we support our business units across our areas of motorsport, public transport, automotive, and healthcare.
Fantastic, thank you. Joe.
Thanks. Thanks for the invitation. So I'm Joe Fitzsimons. I'm a principal investigator at CQT, which is a large research center here in Singapore that focuses on all areas of quantum technologies, including quantum computing, quantum cryptography, and quantum metrology. My own background is in theoretical physics. I did a doctorate in Oxford a while ago and spent some time there as a fellow in one of the colleges before coming over to Singapore 8 years ago. Since then, I've been associated with the Center for Quantum Technologies, and more recently, I'm also a faculty member at SUTD. Most of our research focuses on a combination of algorithms for quantum computers and also protocols for secure computing. So if someone ever builds a quantum computer, can you use it in a secure way without revealing what you're doing and things like that.
Cool, please.
Thanks, Steve. Hello.
Yep.
Thanks, Steve. Thanks for the opportunity. My name is Shankar Silvadore. I am the CTO for Cloud Data and AI Solutions for IBM Asia Pacific. I lead the IBM technical organization that help clients across Asia Pacific to leverage this emerging and new technologies to deliver better outcomes for the customers that we deal with. Yeah.
Okay, well, you can see based on all of the information here, all the self-introductions, that it's an amazing panel. Normally, I try and sort of have a set of questions that I'd like to cover just in case, but we've already got amazing questions coming in. I don't know if I can get them up there, but I'm going to jump right in. I'm going to hold off on the questions that I wanted to ask you and instead go to what the audience would like to ask you, and then we'll come back and cover whatever you'd like. And I'm not good at going, 1, 2, 3, 4, 5, so I'm going to kind of say, here's a cool question, who would like to tackle it? Here's a big one. How do we ensure data privacy and sovereignty? I'll have to think about those two words maybe a little bit differently, but how do we ensure data privacy and sovereignty in the era of big data? How do we consolidate and amass data to extract value? And we're competing with lots of other stages over here, so you'll have to speak up. So this idea of data privacy and sovereignty in the era of big data, where everything is gathering data, how do we try and maintain this idea of privacy? Anyone want to jump in on that?
Okay. Let me start. I think maybe, I think the first thing we got to look at is that I think you need to start treating data like any other tangible personal asset, like a car or a house, right? And I think you need to be able to assert legal ownership rights on this data, right? Much like any other physical property. And once you can do that, right, once you can attribute this kind of information to that data, right, you can now start to monetize it and start using in very interesting ways. So, for example, right, I think at IBM, we're now using blockchain to ensure patients can actually transfer health data, and then taking it a step further to quantify the data in a much more tangible way, so that now you can start to get to use with a lot of choice and control over how you can start to, whether you want to rent, you want to lease, or even sell portions of the data for profit in a secure and private way.
So I think.
Yeah.
So I think everyone's aware in the community that we need to ensure privacy and security through being secure by design, which is fundamental to the system design and incorporation from the first line of code. Within, I guess, my experience in cybersecurity, we always worked on the basis that actually the world is an imperfect place, and so you really needed an approach to an onion layer of security, so different layers, and also an assumption that you were probably always going to be compromised. And so it was defense in depth. And so carrying that thought across to how we implement those layers in security by design is probably a fundamental approach. And I think with my colleague here from the quantum community, it'd be interesting to understand how the challenges and the technology that they're developing can help support that or indeed compromise that.
Joe, do you want to jump in?
Yeah, if you don't mind me saying something. So I have maybe a slightly different take on this. A lot of the stuff we work on is centered around cryptography. And there's actually a lot of interesting things happening in cryptography and have been happening for a while in terms of minimizing the amount of exposure of data in terms of learning algorithms and things like that. So you have things like differential privacy. But also there's a number of different kinds of cryptographic techniques that have been discovered, secure multi-party computation and so on, that do allow you to, in principle, to train models, for example, without revealing the data to the model being learned. So I think, we pay so much attention to blockchain and things like that at the moment, but actually there's a number of other cryptographic primitives that have really important applications for this space.
So let me try and bring it back up a notch, which is, instead of getting into the technical aspects of how we would secure data, let's think about it from the philosophical or the societal. And one of the questions here is, will the Personal Data Protection Act of Singapore, which is based on consent, I give you consent to use my data for a specified purpose, will that be a drag on the potential of big data? So if everybody has to give consent for a specified purpose, does that run counter to what might be thought of as new ways to use data, which is based purely on I grab data and I use it? So let's come back, not from the technical, but from perhaps the policy, the legislative, even the societal aspect of, is it my data or is it society's data?
Okay, sorry. One comment that I want to bring is that from a European company, you may know that we have the GDPR in place since May this year. And we believe that it was a good thing to move to the GDPR because it makes all the company more responsible on how they are managing data. Before that, it may be a little bit a jungle, people taking data and doing things with data that you are not aware of. Now, thanks to the GDPR, there is this consent things, so you have to consent to use the data. But also, in order to push the company, you can be fined up to 12% of your annual income with no cap. So it means that people are really to take very seriously how they will manage your data. And we can see that a lot of countries like Singapore, many states in the United States, like California, Japan, and so on, are adopting now very similar law than the GDPR and making, with respect to the question on sovereignty, some agreement between countries, for example, Japan, Europe, Singapore, Europe, on how people can transfer personal data and use personal data. Then it's just a matter of how you will architecture your services, how you will put in place the right mechanism in order to manage the data. But that the government is jumping into that, putting some law in effect, we believe it is beneficial for the whole industry. When we speak about personal data, slight note, big data is not only personal data. We are doing a lot of airplane and so on. We have a lot of machine, and big data is also machine. And you have the same question, who owns the data? For example, when an airline company is operating a planes, does the engine data belongs to the engine manufacturer or to the airlines? So there's the same question. In Airbus, we think it belongs to the airlines because they bought the system. But you will have the same thing with your car. You have the same things with a lot of tools that you are buying today that have information. And it's not only on the personal information, personal data. This question.
Tsuhan, you had?
I want to route back to Steve's point that is technology's development already making it possible to preserve privacy when it comes to big data computing. It's also true that with policy makings and all these movements happening in Europe and some US as well, that are making people aware of these issues. But more importantly is what I would refer to as education. I don't mean just universities, I mean in general, the public awareness, if you will, what's being out there computed by all these so-called data companies. Case in point, it wasn't not long ago where you would go to a supermarket and then you'll be encouraged to get this, what you call shopper's card. And then every time when you check out at the counter, you tap this. Now, of course, we know that's because the markets are trying to collect your data. But it took a while, many, many years, for people to realize that's what was happening. They thought they were just getting better deals, discounts. And the cashier would tell you, oh, today you have saved $22 because of this and this. But it took me a long while to realize that's what the supermarkets were doing on them. So I want to take this opportunity to mention this thing that we're trying to disseminate here in Singapore through the AI Singapore program. Just a few weeks ago, we announced what's called AI for E, AI for everyone. It's kind of these short courses that you can take, seminars even you will. You don't need to know anything about coding. You don't even need to know anything about the algorithm. You just need to know what AI is doing for you and of you, and maybe at times taking advantage of you that you just don't know. So I would like to say education is important, not just in the form of university degrees, but also all these short courses, seminars. I would encourage everyone out there to really every once in a while check out these things. Don't just read up things on New York Times or Washington Post. These are all things that people talk about already. However, there are more things that's happening that we're just not aware of. So education is useful.
So understanding how technology works and understanding the benefits and challenges of technology. So even though everybody in the room understands that when you click on consent, you are not reading the 32 pages that come with that agreement. You basically say, I accept. So whether it's iTunes Store or any social media, so we already engage in this idea of I want something, I trade something. So your point is, the more informed and open we are, then that's part of our personal responsibility also. Let me move on to this idea of data. I think we'll all agree that there's more and more data, and it continues to grow in a very significant way, doubling every 2 years, however you want to look at it. Now the question becomes, how do we make sense of useful data? Because it's only a tiny fraction of the data that's actually meaningful and actionable. Who wants to jump onto this question of having an ocean of data doesn't mean that the bucket that you might scoop is actually worth anything?
Okay, Steve. So can I answer the last question as well as this question with consideration to healthcare? So everyone understands the challenges of sharing healthcare data, and I think everyone acknowledges that consent needs to be at the forefront of any data exploitation. The digitization of healthcare systems and the personal medical record has obviously made it very easy, or there's a potential to now bring that data together into population health data sets that allow us to make really significant strides forward in stratifying and understanding the demography of our populations and tailoring healthcare to the person. Now, the challenge of just employing big data, AI, machine learning techniques to those data sets is fundamentally you are highlighting something interesting, but whether that interesting thing that you find through clustering or regression is actually meaningful is, well, will be determined based on the features in the data set. So the approach that we take within Applied Technologies is actually to employ those types of algorithms, but really back them off with a bottom-up approach based on the contextualization of the disease and disease progression. So through Formula One, our background is in time series analysis, and so modeling a disease according to key time series points and building up the context around the disease bottom up, and then fusing that with the top-down approach allows more significant insights. So it's not just more data, bigger data, but I think it's the right sort of data with the right context at the right frequency. And I think another example of this is where we're working to deploy Formula One technology within public transport applications. We're deploying the Formula One sensors, the connectivity solutions, and the analytics environments for visualization and predictive maintenance and condition-based monitoring. And the interesting thing about deploying the Formula One sensors is that they are logging data at higher frequencies than would be traditionally deployed on that kind of infrastructure. So frequencies of 1 kilohertz to 10 kilohertz. And that means that within the data, you're now seeing anomalies that you might not normally detect, and you're seeing them earlier. So is it about big data? Well, that's certainly more log data. It's a higher frequency event data. But again, I think it's the right data at the right time, and crucially with the right context and consent.
Let me pose a question, just pose a question here. I agree on this idea of health-related data is the person, but not exploiting the data, not commercially selling. Is there an argument that says with appropriate anonymization, there has to be, for some societal override, some use of data without consent? As in, everybody has to consent all the time, or we say, as long as some of the most obvious links to your person are removed, and I know the argument is you can always reconstitute identity, but how do we think about things that are also societal impact versus personal in impact? These are the ethics, the tough part of how we move the conversation.
So I think the way I'd answer that is if you can anonymize the data sufficiently and introduce enough noise to mean that your queries can be privacy preserving, because obviously, you know, if there's a patient in Singapore with a rare disease, rare form of cancer, and they live in a particular region, of which there's only 3 people in Singapore,
Understood.
Then ultimately you can reveal that person. So we're having to, so then the ability to do this comes down to how seriously and how completely you create that data set for onward exploitation.
Yeah. Tsuhan, did you want to?
I know we started the session with this privacy, and now it's all going down the ring. I do want to bring this back a little bit. Yes, we all talk about big data. Indeed, what's driving this wave of AI for the last 5-10 years is the availability of data and processing speed of the computers. what to me is even more important than the privacy issue is what we refer to as ethics or moral issues, if not, whatnot. Yes, people all worry about singularity, computers wiping out humanity and all of that. But I want to make people aware that even as of today, what we think of as free will, or you think you're making your decisions, you're taking all this input from social media and then you make a decision. Is that free will anymore? Noting that this so-called social media effect to you is already being manipulated. And we've seen consequences happen in US, happen in Europe. It's getting crazy now. So rather than just worry about privacy, we all should be careful that even before singularity hits you, we're already being very much manipulated by the data that's fed to us. So don't forget that. Don't forget that. Okay, I want to come back to the ethical issues. Oftentimes people worry about, when computers are making all these decisions, what's going to happen for humanity. I do want to encourage people, those of you in law schools, you do know that your jobs are going to be taken away, right? Studying law or whatnot. However, there's something new coming up about job creation. And this is what AI brings you, new jobs, so to speak. When an autonomous vehicle go out and hit someone, who is responsible? Driver, passenger, he was not even driving. The algorithm developer, AI researchers. No, they say, I just throw these layers of neural network, they just somehow optimize themselves to do things. Data. How about those people that were paid by hours to label data of these images and say that's a pedestrian, that's a cycling, and then these people should be detected and therefore algorithm should work. Maybe they neglect to label that particular circle, that particular pedestrian, and that's why when pedestrian came out that way, the car would just go around and hit it. We don't know. We don't know the answers. But there's more to discuss now that when such things happen, all your lawyers in the profession or students in law schools, be ready. These are new jobs that are going to be created that you will have to help us sort this out. I don't think it's just an ethics issue, but a lot of legal issues and moral issues even that we will have to address. So don't wait for the singularity to hit us. We're already in it. All
right, so you heard here, it's whatever you think about Ray Kurzweil and the view of the singularity, you've heard Tsuhan say that we're already entering we're entering the black hole from which there's no escape.
I just want to add something here in terms of the big data, right? I think it's important to note that more data with more attributes is not necessarily always a good thing. Let me give you an example, right? If you got an AI system, you built an AI system that is shortlisting candidates for a particular course in a college, right? And if you train that AI system based on historical data of graduated students from primarily from a specific gender or race, there's a high likelihood that if you get applicants from a differing background, they're not going to be successful, even though they may be more qualified or equally qualified, right? So, but interestingly, ironically, what we're finding is that, the solution to reducing bias and discrimination in AI systems is actually AI itself. For example, we're now exploring AI that can actually build trust in organizations by helping to identify if a specific data has got bias, and taking it a little further down the road where we can actually test AI systems or models themselves if they have a tendency or potential to introduce bias or unfairness, even if the data is fair or not.
So there's sort of a connection to what Tsuhan was just saying, which is if there's an algorithm that can do a better job detecting and neutralizing or eliminating bias from an algo built by a programmer, then already we're sliding into singularity, which is that there are things done by machines.
Precisely.
But this whole idea of bias is a big and very significant topic. Let me come back on big data for a moment, because this is something that has come up in a variety of questions. And it's about the using or building of algorithms. So if we assume that there's more and more data from more and more sources, your point, Frank, was There's how many million sensors, and then there's all of our phone calls and snaps, et cetera. But are we not building, I mean, is it not really about algorithms now? Because there's plenty of publicly available algorithms. Is it more about quality of data, specificity of data, tagging of data, more so than in a new algorithm or newer algorithms? Anybody want to jump in? Joe, I know you have a particular view on algorithms.
Sure. Yeah, so I mean, one issue you have is if you have a huge amount of data, you're very limited in terms of the types of algorithms you can apply to it, because you're just compute limited. So if you have terabytes of data, then there's a limited set of things you can do to it. Many machine learning models require matrix inversion, and it's very hard to invert a matrix beyond maybe a couple, tens of thousands by tens of thousands. So if you've millions of items in your data set, then you run into trouble. On this front, it seems there's some advantage to quantum computing. We still don't have processors of the kind of scale and quality we need in order to be able to actually implement any of these, but hopefully they'll come. But one advantage of that paradigm is that you can query a large database in basically a single memory query, and you can have the entire database affect the output of your algorithm. So it gives you a much wider variety of ML models that are accessible, that aren't compute limited. But that's always going to be a limit in the classical world. The tools you have available aren't the full set of algorithms that are known. It's only the ones that are suitable for the data you have, given the amounts of data you may have.
So let me come back, Tsuhan, to something close to your heart. So would it be a discussion about, let's go for healthcare and images. So is it a discussion about better algorithms or more accurately annotated and better quality data sets feeding algorithms?
Very, very good question. I want to answer that question by asking a question to the audience. How many of you have heard about this thing called deep learning? How many have not heard about deep learning?
Hopefully everybody.
It's rather interesting. This thing referred to as deep learning that's kind of dominating the whole community of artificial intelligence. It's really a rather small subset of all the solutions available in what we refer to as artificial intelligence. And the reason that it's dominating is really that it feeds off from data, lots and lots of data. The more data it has, the better it performs. In fact, it's so powerful that the following is true. Whatever your hypothesis is, you want to say this is true, this is not true, I will find the data you need to support your hypothesis with deep learning. So that's scary. What I'm trying to say is that this thing referred to as deep learning, one, is not deep at all. Yes, you have a few more layers of neurons. Is it learning? Sorry, it's not even learning. It recognizes patterns. That's all it does. So we have to be careful that when it comes to AI research, there's much more to study. Even my good friend Jeff Hinton, who created all this new wave, will agree to that. This is what's in now, but it's not all of it. The opposite is also true, that is data is what we all feed off. Be that deep learning or anything else that's going to come from the horizon. Data is important. Therefore, we have to be very, very careful, back to what I'm saying, right? If whatever you want to say is true, I will find data that supports the truth. Sometimes the truth is not true. So
I thought I've heard that, yeah.
The point is that let's be very, very aware of where we're living, the kind of where we're living now, and the kind of data that's being collected to do all kinds of things, some good things and not so good things. And the fact that data in itself, when biased, can create all these biased conclusions. Are we all going to recover from where we are today? I think so. I still think technologies will bring us back to normalcy, but it's also true that we need people to be more aware of the bias already in, be that induced by AI or even bias that we all live in already. So be aware.
We're all learning systems, so we're all a product of what we've seen, what we've been told, what we've heard, and so that shapes us just as it would shape machine learning. We've got a lot of support for this question, so I'm going to ask for anyone that would like to tackle it. Please give insight into the state of translating unstructured data into structured formats. So if we think about this idea that most of the data that's in circulation today is unstructured. First of all, is the question something that makes sense, as in, do we need to turn unstructured into a structured format, or how does anyone on the panel want to answer this question? It's now got the highest number of upvotes, so it's important we take it.
Okay, so I think, you know, within the community, we've advanced quite significantly to be able to turn most sorts of unstructured data into and apply some sort of structure to it. So we've got OCR, optical character recognition technology. We've got natural language processing technology. And so, you know, handwritten notes can become digitized. And then you can apply n-gram analysis or, you know, standard analyses across the written words to try and pull out patterns and semantic meaning. I think where we're still challenged is around the application of a taxonomy and ontology to the data set. So again, you know, within healthcare, each of the different types of encoding across, you know, HL7, FIRE, etc., they're really quite complex to structure and to really codify in a single harmonized way, as opposed to capturing the meaning of the domain, but not so much with true accuracy. So I think there's a lot of work to do around the domain-specific ontology and taxonomy construction.
Okay, I want to make sure that we respect the time of the overall session. So here's what I'm going to do is there's 5 of you. We have 5 minutes. So by simple math, everybody gets a minute to highlight how they feel, how they would like to articulate their view on this concept of big data, and how should we approach it, think about it, be afraid of it, embrace it. Shankar, do you want to lead us off?
Sure. So, you know, I think, you know, first of all, right, I think you need to build trust and transparency in anything related to any human-centric, data-driven technologies. I think that trust and transparency, if you look at from an AI perspective, right, AI should be explainable and transparent. You should be able to explain what data that AI system is trained on, who trained that AI system, and explain as well how did the AI system come to a specific conclusion or recommendation, right? I think that whole premise around trust and transparency in everything that you do, I think is going to be critical. And helping consumers and citizens have better control over their data and understand how the data is being used is going to be critical as, you know, as this data evolution explodes, right?
Joe.
So I think, in principle, the idea of big data really holds a lot of promise. And if we can master the algorithms, if we aren't limited by computational power and so on, then there's a lot we can really do. I mean, one advantage computers have that we don't have is that, in principle, they get better each year. We keep getting faster and faster computers, getting more compute time. And this means that, in principle, the models that they can implement can be much more complex than something we could necessarily understand. So at the moment, still the human brain is far more complex than any neural network you're going to implement anytime soon. But the long-term promise for this, I think, is that computers are in principle capable of building some form of understanding about much more complex systems than we are capable of understanding. So, for example, trying to learn how the economy works. Humans can have a picture of that on various layers of abstraction, but a large enough computer can understand how every part is interconnected in a way that no one human can.
Thank you. Andy.
So I suppose I'm thinking a lot about data bias at the moment, and data bias is both good and bad. So considering the good, we've just had a fantastic Formula One race weekend, and the way data is analyzed in Formula One is through simulation and modeling, which is every aspect of the car, the components on it, are modeled from fundamental systems physics models. So the tire, the suspension strut, into chassis, engine, and overall aero package. And those models are simulated, and the data is compared against the telemetry, real-time telemetry coming off the car. So that's a white box fundamental system modeling approach. More recently, we combine that with the data sets captured from the telemetry systems, not to validate in the way that I just described, but actually to augment through Bayesian inference techniques. So the data there is biased by the environment, it encodes the environment, and the parameters can be proxied as, the data can be proxies for parameters into our models to refine them and cover parameters we have no models for. So that's where the bias of the environment is good. I suppose the challenge on the contra side is that we're using data sets to train algorithms that are largely, at the moment, produced via the human condition, so from our environment. And that means we're inherently encoding bias into, bias of the human condition into our solutions and our insights. So going back to the point from my colleague on my left, if we're going to progress with bias, we're going to need to eliminate and have machine algorithms start to produce data sets themselves.
Okay. Frank.
Thank you. I may be a bit controversial, sorry. For us, big data is not only AI. AI is a very small part of big data. And what we have seen in the last 3 years of working on this topic, big data, is that the most critical aspect of big data for us at the beginning is how to connect data that have nothing to do, because we have a lot of information that lie in silos. For example, you have in our business data that lie in airplanes, data that lies in a computing system, in info operation, and so on. And we need to be able to connect all those data, to have the right platform to connect all those data. And the first issue then is how you have the right platform that will help you to connect with those data and then to do your analytic works. And what we have found out in the last 3 years is that only 20% or 15% of our analytic work is supported with AI tools. Most of the analytic that we can do is based on common sense, simple algorithms that brings a lot of values very quickly, and that help us to build this ontology, all this experience, and all those use cases. At the end of the day, it's true, AI can help on difficult topics. For the unstructured and structured format, what we are looking also is the human interface with the machine, and this can help, AI can help for the human interface. And all these big data things at the end of the day will be how can we exploit the data, because we don't believe that the AI will replace the human. We believe just that the AI will help the human to take a better insight, better information, due to the amount of data that is impossible for a human person to investigate, basically.
Thank you. Tsuhan.
I'm not going to sound too much Elon Musk-y and worry about singularity. I do want to say that we're already in it, it not being singularity, it being AI already shaping the way we think, shaping the way we make decisions, is part of us. So rather than saying that we should worry about AI replacing humanity, really let's find ways to embrace it and make it useful. It has been used for many good purposes. All my panelists have already mentioned. But first, it's also being used in a lot of cases that the consumers are being taken advantage of this and that. Go back to learn more about AI rather than being just scared. If you want to come to NUS, welcome. Or take up all these free courses from AI Singapore. What AI is going through, to me, one final remark, is not that different if you go back to humanities or human history. When human, how do you say this, created fire, or invented or discovered, however you want to say it, it took humans many, many more years to realize that fire can be put into good uses. With technologies, with regulations, safety code, when you build up these civil structures, right? Fire can help you, but you also have to find ways to make it useful. That's actually what AI is going through now. I don't know we have come up with enough policy making for AI to be safe just yet, but we are definitely working on that, including many of us as researchers. So don't be so scared about AI researchers. We're trying to do good things. Eventually, we'll tame this beast and make it useful.
Okay, so the way that we can think about it is just to parse briefly into, there's sort of lots of data coming from lots of sources, like all the millions and millions of sensors, a little bit less emotional. Then there's our data, our health records, how we live our lives, our financial records, whatever it might be that's about us. The more that we are thinking about how this data can be shared, used in ways that still are privacy preserving, but more openly sharing and using for larger societal goals, because we still like to think about us, but we need to also think about we, because we do have some pretty significant challenges as humanity with food scarcity and lots of things that are facing us, antibiotic resistance rising and so on. So I think if we can continue to talk as opposed to just say, that's a tricky concept, let's move on. And that's what I hope today as one way of at least opening the door and thinking some more. Thank you for all of your perspectives and points of view, and lots for us to continue on with. Ajit, back to you.
Thank you very much, Steve.